Hi, everyone. Thank you for joining us here today to learn about AWS Transform for Mainframe. The service was made generally available earlier this month, and we're looking forward to sharing more and hearing about your experiences building with AWS Transform. My name is Meena Vemba-Subramanian, and I'm going to be joined here today by my colleague Vaidhi Sankaran, who leads go-to-market efforts for mainframe modernization here at AWS. And I work with the service team, and we building AWS Transform. And I lead product management on the team. So if you found your way here today, I expect you who've worked with mainframe systems in your career either do so today or are looking to modernize these workloads. So we'll start our conversation here today with a little bit of a primer to contextualize these migrations and what makes them challenging. In that context, I'll introduce AWS Transform from Mainframe, tell you a little bit about the end-to-end workflow that we support, the various features that are part of the product. And finally, we'll dive deep into a couple specific features that we're excited about. Then Vaidhi will show us AWS Transform at work in the context of a demo mainframe application, so you get a feel for what the experience is and what the UI looks like through the modernization process. Finally, we'll end the conversation with a little bit of what we've been hearing from some of our customers and partners who've used the product to date. Looking forward to sharing all of this with you and answering any questions that you have along the way, and to continue the conversation after today as well. So despite what we've heard about the growth in cloud adoption over the past years, we still know that over 70% of workloads are still running on premises. And within these workloads, 70% of them are over 20 plus years ago. And what we often hear from customers is as organizations have evolved and their needs have changed over the years, people have built applications in layers over the legacy systems, making it really hard to unwind discrete applications and understand choices that were made on architecture years ago or generations ago. Unsurprisingly, customers that have successfully migrated applications find that it takes over 1.5 years to get from point A to point B. And there's a few factors that we hear across customers in different verticals that make these migrations particularly challenging. First is the time and resource commitment it takes to really unwind the complexly and tightly bound layers of development over the course of years. Teams today are limited in how well they can scale the existing applications due to either physical constraints or the costs associated with scaling the existing starting point. Finally, the pool of talent that really understands the legacy system deeply enough to continue to develop on it or to continue to maintain it is continuing to shrink. Fortunately, we've seen something change over the past year with advances in technology. LLMs allow us to leverage the automation that's newly available to do the complex heavy lifting while reserving the high judgment decisions for people who understand the context of the business in addition to the technology and the hard constraints. LLMs allow us to now process millions of lines of code on the order of minutes to do things like translate from one programming language to another, as well as to generate documentation and natural language representations of code. Previously, this understand phase would take teams weeks and months to get to this point, and now we're able to execute on this documentation and initial analysis aspect in the order of minutes. When we combine this LLM-based approach with graph neural networks and formal methods, what we find is that we're able to produce highly accurate results for code transformation because we understand not only the semantics of the code, but also the structural elements of your applications and how different programs are related to each other. Finally, bringing all of these capabilities into an agentic platform with AWS Transform lets us build a cohesive, intuitive experience for teams that brings different tools into the same interface without having to force teams to train on multiple platforms and to move data back and forth in order to use all of them together in a project. So in that context, I'm excited to introduce AWS Transform, the first agentic AI service for large-scale migration and modernization projects. AWS Transform today supports a few different workloads. First, we support the VMware agent supports migrating VMs to Amazon EC2. Next, we're here to talk about the mainframe agent for modernizing IBM ZOS applications. And finally, the .NET agent helps in modernizing Windows-based .NET applications into Linux. So let's take a deeper look at AWS Transform for Mainframe. The AWS Transform Mainframe experience leverages foundational LLMs, including the best-in-class LLMs on legacy technologies, as well as AWS in-house LLMs such as Nova, in order to create task and domain-specific agents for each step in the modernization journey. This experience really automates the labor-intensive, time-consuming tasks associated with mainframe modernization to take that end-to-end project time from the order of multiple years down to the order of months. And we balance this by ensuring that we bring humans into the loop at the key points to make those high judgment decisions, to ensure that we're not just accelerating the parts that we can, but also increasing accuracy and de-risking your migration by ensuring we're making the best decisions at each point along the way. All of this happens in a unified web experience that's really tailored for that collaborative, iterative process that's intrinsic to the nature of these projects. AWS Transform from Mainframe is a pattern-agnostic experience. From talking to customers in multiple different industries, we know that there's not a one-size-fits-all approach for mainframe modernization. Depending on the context of your application, you might have some programs that you want to move forward as is. For example, there might be a regulatory enforcement context where regulations have not changed in 50 years, and you want to, like for like, make sure you bring the existing functionality over as is. Automated refactoring for function with an emphasis on functional equivalence will be the right path there. There might be still other aspects of your applications where you want to understand the existing business logic and potentially make changes or adapt that business logic in order to bring it into the modern context to meet the changing needs of your organization. Here, we are working on continuing to support the reimagine or re-architecture path by beginning with that foundational business logic extraction and understanding of what the programs today are doing. AWS Transform offers a variety of capabilities that you can pick and choose in order to tailor the end-to-end workflow for the objectives that you're trying to meet in your modernization project. So I'm going to walk through now the distinct steps in the workflow and then we'll highlight a few specific steps. Any project begins with code analysis, which basically gives you a lay of the land on the different types of files associated with your code, gives you a view on the dependencies between programs within your code base. It also helps you identify any redundancies across your code base or any files that are missing based on the dependencies that we've extracted. The AWS Transform UI lets you look at this information inline in the UI in order to understand what actions you need to take to complete your starting point source code in order to move forward. Document generation is one of the steps we'll go a bit deeper on, and it essentially lets you produce natural language descriptions for both technical and business users. And finally, we know we're modernizing applications, not code, and these applications map to teams and specific business functions. Decomposition lets you break down your monolith into specific domains to help you with your migration planning and sequencing across the project. All along the way, you can provide input based on your organizational needs in order to modify what you're doing with each step and to change your plan if you need to. And you can pick and choose the steps that are most relevant to your project. Finally, we automate the refactoring of code, and we provide another feature called Reforge, which lets you restructure your code in order to make it more readable and easier to maintain for your native Java developers who will be carrying the applications forward. Finally, AWS Transform also provides infrastructure as code templates to accelerate the deployment of your transformed applications into AWS when you're done modernizing. So let's go a little bit deeper on a couple of these features. We'll start with document generation and what we support here to promote the understanding of your mainframe applications. So the first aspect of document generation and business rule extraction is in generating technical documents that detail how each program works. And the target audience here is the developers who are going to be owning and maintaining the modernized applications moving forward. Technical documentation does things like providing an understanding of how data is accessed, what those access patterns look like through the course of a program, helps you highlight the dependencies and the discrete logic being executed in each program. It also extracts the control flow to really understand the relationship between programs and represent this in the context of technical documentation. Business rules extraction instead helps you understand what each program is doing in the business context. Business rules, when they're extracted, are put in the context of a visual representation of the logic, which is presented in natural language. So a business user is able to follow the chain of logic and understand what decisions are made, what inputs go into them, and what the impact of these decisions are. We also enable things like visualizing BMS screens inline so that a non-technical persona coming in can get an understanding of what the user experience being presented on the mainframe context is today, so that that can be translated and adapted for the modern context based on the target users that you have for the modernized application. So let's switch a little bit and look at what decomposition looks like as the next step. Based on all of this understanding that both the technical and business users have built over the course of the project thus far on how and what each program is doing and what the application looks like as a whole, the next step is to break down the monolith code base into distinct business domains and applications, and to sequence them for refactor or whatever path you choose further down the road. As part of the analysis, AWS Transform extracts a dependency graph, which helps us understand the interconnectedness within the code base. Previously, going from the monolith to a breakdown of work groupings based on these applications was a manual classification process. You required technical expertise in not just how to navigate a dependency graph, but also needed a deep understanding of the mainframe application to intuitively identify where the boundaries could be. What the automated decomposition capability does in ATX today is automatically detect and recommend boundaries that might define these distinct domains and applications in order to compose these distinct groupings, significantly accelerating this process of beginning with that monolith and ending with domains that you can sequence for modernization. Of course, this is a great example of where humans are going to be bringing in unique contextual knowledge. You're going to understand your organizational structure, which may not be directly reflected in the code or in the dependency graph. And AWS Transform for Mainframe provides HITL options, human in the loop options, for you to come in and specify seeds and bring in this information into the automated decomposition process to arrive at a more accurate and organization-specific result for decomposition. Next, let's jump forward and look at some of the new capabilities we're introducing with automated refactor. AWS Transform for Mainframe automatically refactors COBOL to Java in the order of minutes. Traditional systems that place an emphasis on the functional equivalent sometimes tend to carry forward COBOL semantics and structure when they are refactoring code. In order to address this, we introduced a new feature called Reforge to help improve the experience for teams that are going to be maintaining the code down the road. Much like metal is melted down and reforged to fortify it and make it long-lasting, Reforge leverages LLMs to process refactored code using a multi-agent process And what these agents do is restructure, critique, validate, and then refactor the Java code. The result is improved readability, making it easier for Java developers to work with this code, maintain it, and carry it forward. This multi-agent process also inserts human-readable comments at a class and method level in order to ensure that this code has longevity moving forward and no longer carries forward the same structural and redundancy components that tend to show up when you go from COBOL to Java in a like-for-like manner. Through the workflow, our goal is really for AWS Transform to act like a member of your team that's learning and collaborating with your team as you make progress on the project. The experience begins with negotiating a job plan specific to your goals by using the AWS Transform chat experience. Then we talked about code analysis as the starting point, followed by document generation to really help your developers as well as business users understand the context. Then you have your subject matter experts weighing in for the code decomposition and planning aspects. Finally, the next step is automated refactoring and leveraging Reforge in order to restructure the code and ensure that the architecture maps your modernized application needs. And finally, today we connect this experience to be able to download modular arrays code and automate deployment into AWS. I'm going to, at this point, hand over to my colleague, Vaidi, in order to walk us through a demo of AWS Transform at work so we can get a sense for how these different steps and features that we looked at connect together to help accelerate your modernization projects.
Thank you, Meena, for the wonderful introduction of the product. Hello, all. We will soon right away jump into the demo. So we heard about how do we use analysis, documentation, code decomposition, and how do we transform a real working application from mainframe to Java. And let me start with my screen share. I hope my screen share is visible. So here, we're going to start taking a real application called AWS Card Demo. This is an open source application, which is a COBOL native application that was developed for the users to play around with mainframe modernization tools and techniques. And we have taken this tool code base, and this code base will go into the S3 bucket. And the S3 bucket serves as the input repository for the AWS Transform to consume and do the modernization in a web-based approach. So you have this legacy app in a zipped file, and that sits in your S3 bucket. Accessing AWS Transform is pretty straightforward. All that you need to do is go to the console, search for AWS Transform, and that gets listed like this. And when you click on AWS Transform, it takes you to the Transform URL. You can add users or user groups based on your identity center configuration. I have a pre-configured user, which is myself, on identity center, and that gets listed here. So I can select the user, or I can select a group and assign it to the user groups. And in the setting of AWS Transform, you see a web application URL, which is used to launch the service. Let's get immersed into the journey of AWS Transform with this. So I hit the URL, and it's going to ask you for the login, and it'll take you to the workspace that is created to start your transformation journey. You have options to create multiple workspace, and you have option to add collaborators to the workspace. I can add my identity center users, which were subscribed to AWS Transform, and I can select the role as contributor, approver, or view-only access, which makes this product a one-stop shop for all the collaborators to track, plan, and be a part of the mainframe modernization journey. We set up connectors to ensure AWS Transform can access your source code. The source code that is going to get transformed sits in the S3 bucket, and the connector is set up and approved by the administrator to ensure security. I have already pre-set up the connection to the legacy application bucket where my code repository is sitting as a zip file. Chat is a very important feature to improve our user experience. You can chat with AWS Transform in a native language to start your modernization journey. All that I have to tell is start a mainframe modernization task. AWS Transform will interpret the human language, English, and it will provide you a recommendation on how do you want to progress with your task. So with a mainframe modernization task, you have a couple of things to do. One, you can analyze your code, you can generate documentation, you can decompose your code, which is breaking down your monolith, huge chunk of code into multiple domains. You can plan your migration sequence, and you can do a transformation to Java. The second workflow, which is typically analyze and extract business logic, accelerates our reimagination of mainframe applications. With business logic, you can extract them, understand the program logic, identify which are all the business logic that are still relevant to the current business standards, and work with your business analyst to prioritize them, do code scaffolding, generate tests, and the use case is endless. So let's start with a refactor. And I also have a predefined or pre-executed job plan to demonstrate the success of each. So I'm going to select one, and the AWS Transform will come back and ask for a confirmation based on the selections we made. So it is going to create a new job named mainframe end-to-end. It's going to select my objective. I can chat interactively to refine or redefine the objective. Let's say if I don't want to decompose, I just wanted to do a transform. I can say change the objective to just analysis and transformation. Let's assume I need to run a full cycle job flow. I'm going to say proceed. It takes my input and it gives me a button to click confirming my transformation job plan. I hit on create job, and this is how AWS Transform will provide you the recommended job plan to run through your end-to-end modernization journey. So here is the job plan. You see the steps that were defined, selected by us, listed here. As a first step, I can add collaborators and send it to AWS Transform so that they have access to my job and they can collaborate on tasks, view the outputs. The second step of the modernization kickoff is to supply the input. So you need to provide the source code bucket, and let's grab the source code from S3. So here is my application. I'm going to pass the S3 URI back to AWS Transform and approve it. So now the source code is captured, and AWS Transform will validate the connections of the source code. It will grab the source code from the S3 bucket, which is typically going to sit on a customer's S3 account, and it does the in-memory processing to do the analysis. You'll soon see the analysis process getting kickstarted. There are three key tabs that we have provisioned to track the progress. To start with is the work log, which will tell you what are your agents doing. The agent has started the code analysis process now, and you can see the progress here. The second tab from the backward is the collaboration space, and this acts as a source for the human in the loop to provide inputs to the AWS Transform agents that is doing modernization on your behalf. And the third tab is going to be your project dashboard, which tells you at every single agentic step what is the progress. And this tab is active and it will publish the report only after a process is complete. While the analysis is in progress, I would like to show you a pre-executed analysis on how it looks like. Let's take a comprehensive job that was completed recently, and you see the code analysis being completed, and you view the code analysis report here. To start with, it lists you all the files that were identified, and as a first step for the developers to have a comprehensive source code, we identify these missing components. Some may be dataset, but there will also be a source file, program, or a copybook that is actually in the calls of a program, but not available on the library during the analysis phase. Let's say there are a COBOL program which is calling a subprogram that has multiple copybooks, but none of the copybooks have been served as a source of input in the S3 bucket. Our analysis capability will identify those missing components, and it will provide the report saying what are the components that the developer has to go behind and assemble it to make it a complete puzzle. The third tab is identically named file. Sometimes you will have same program repeated twice. In that case, you have an option to view those files and compare, and then decide which file you need to have it as a source and which file has to be neglected. Sometimes you will have a duplicate program ID used on COBOL, and those components will also get listed here. Looking at the dashboard report on the analysis, that helps every customers and partners understand their mainframe portfolio. Now it tells you how big is your BMS, how big is your copybook library, and how big is your COBOL, JCL, and also gives you the number of components by file type, which tells you how intensive is going to be your mainframe status. The analysis process is complete, and let me pull up. So the analysis is still in execution here, and once the analysis is complete, and once we assemble the missing code back and rerun the analysis to have a comprehensive analysis report, the subsequent steps get triggered. The next key feature is the documentation feature. In documentation, it uses the source of analysis and the dependency graphs created during the analysis phase, which tells you how those components are interrelated to each other. And it gives you a comprehensive as well as a summary level of documentation for your COBOL and JCLs. You have option to select summary or detailed functional specs, and you can select components. In this example, I just selected one particular component for which the documentation has to be generated, and you will see a button called Submit the documentation to AWS Transform. And once the documentation is complete, you will be able to see the documentation in a PDF format as well as in an XML format in the S3 bucket. You also have an option to select and view the documentation online using AWS Transform. Let me pull up one of the detailed documentation that was executed. I have a mainframe documentation job, and I have selected a detailed functional spec, and I have taken one of the couple of complex program within AWS Car Demo. Let's review and see how a complex detailed documentation summary looks like. Here is my documentation. You see the high-level program overview, the purpose, and you see the number of logics being extracted. There are close to 14 logics, and you have data flow dependencies described. You also have the source of input information, if it is database, if it is input file or the output file, followed by the error handling routine handled in the program with any integration information available. You can also select download here. See, it's a 30-pager document with very detailed information about each and every aspects of how a comprehensive documentation should look like. The use case for documentations are a couple. Number one, with transitioning workforce and with modern developers focusing more on the full stack, including Java, it is important to not lose the application understanding and the knowledge with the transitioning workforce. So these documentation acts as a source of the knowledge. It can become your knowledge base, and you can also have a chat integration. You can ask what this particular program is doing with the AWS Transform chat feature. Let's say, explain the purpose of. It tells you, and it makes the interaction pretty easy for the developers to tell how the documentation is being used and what are the application knowledge that are embedded within the documentation. The second major use case is actually the program logic. If you're going through the reimagination journey, these program logic can help the business analyst make a decision on how relevant are they to the current market and the business and refine them accordingly before they go through the refactor or the reimagination journey. Once the documentation is complete, the next step is code decomposition. Let me show you how the inputs are being taken for code decomposition. I have already completed a documentation step here, and you see the decomposition agent has started seeking inputs to the user. Here, with actions, I can click on create domain, and I can create a domain called as transaction. When you break down a monolith, largely spaghetti mainframe code into multiple domains, you can either slice it in a technical side or you can slice it as a business domain. A typical example for a technical domain would be a report generation process, a data sanity process, a data quality check process, data mix and match, or data refactoring process. It really depends on what kind of technical functionality are you performing with a set of batch jobs. Uh, Typically, if you take business domain, let's take payments as an example in a credit card industry. A payment will have several business features, which includes setting up autopay, calculating minimum due date, calculating the minimum pay, statement balance, and everything. So these could act as a domain. Let's say identifying transaction is one of the payment domain. So I'm going to create a name called transaction, and I'm going to identify sampling seed. So let's say transaction could be a sample, and I'm going to say I'm going to mark it as seed. Seeds are nothing but a sampling augmentation. Let's say there are 50, 60 jobs that are associated with transaction. All that I have to do is provide three important seeding example information to the decomposition module. And when I create the decomposition with these seeds, it uses a semantic search with all these seeds and identify the parent, child, and the sibling of these seeds to make it a comprehensive collection of domain. And once I have multiple domains like accounts, cards, transaction, a common component where all the shared components goes in, and I click decompose, AWS Transform performs the decomposition, and you see I had one seed and two seeds for first two domain, account and card, and I had three seeds for transaction. Transaction is a very lean domain in this card demo, but if you look at the account and card, based on these two seeding samples, it was able to identify 112 and 109 files subsequently that belongs to that particular domain. Now you see the transaction being refreshed. I see 112 files that belongs to the transaction domain. So you can also view a graphical representation of how these domains are interrelated. Let's start with the domain view. The domain view tells you what are the interlinks between each domains. I have my card domain that talks to transaction domain, that talks to account domain, and that also has integration with common components. However, if you look at account domain, that is pretty standalone. It only calls some program from common component, but it doesn't use a card or a transaction uh, in that module. Same with the transaction. There is no outbound call for the transaction. There are only inbounds. And the only outbound call that you see is to the common components. Getting into the dependency view, which gives you a cluster of galaxy that tells you how each components are interrelated to each other. You see, there is a file, there are a JCL, and if you want to know how these JCL has dependent components, I can click on this JCL and pull them into the corners. I can continue to explore the subcomponents to see where the connection is going. You can filter it and select it based on domain. Let's say I want to do account domain. There are three files with 226 lines of code that belong to the account domain that can be filtered and extracted. You can also extract a subgraph and you can review its parent, one level above and all level, to know how the onion gets peeled into parent and child relationship. By this way, you perform a graphical analysis on the spaghetti code and finalize your domain breakdown. Let's say I have confirmed my decomposition step and I send it to AWS Transform. Once the decomposition is complete, AWS Transform uses its AI capability to generate a plan migration wave, which tells me what should be the sequence of my domain-based modernization. Which domain should I modernize first, which domain I should do second, and which domain I should do last. You can see the progress on the work log on where the step is. So the AWS Transform is now creating a recommended request to review the plan. Here is my modernization plan. The chart says start with the common components, and since all your transactional account modules are pretty small, in case of card demo, you can do a parallel threaded migration. Um, in wave 2, you can do all the 4 domains modernization. And whatever disconnected domains that are there, you can do it later. Let's say the business wants to do the disconnected domains first. I can add a preference here and move the prioritization up and down to select how do I want to change my domain. Let's say I do this as 1. This makes my disconnected domain as first priority, and I'll be able to add and regenerate. So by this way, you can plan your modernization journey, and once your planning is complete, you'll be able to send the modernization to the refactor engine and then start domain-based refactoring of your COBOL to convert them into Java code. Let's wait for AWS Transform to complete my instruction. It is updating my modernization plan sequence. I can pull up existing job flow to show how the transformation works. Once my domain is complete, I can select a particular domain and select refactor option. And this refactor option will transform my COBOL to Java, my JCL into Groovy scripts, and help me run those transformed code into AWS Mainframe Modernization Service by providing an infrastructure template via chat interface. You'll be able to review the results and extract the converted code in the S3 output. And there is also a viewer which tells you what are the components ignored and what are the components being transformed. The copybooks will obviously get ignored because only program gets transformed, and the copybook being called within the program will eventually be a subset of that program. So let's look at where we stand on the end-to-end process. While it is still processing the refactoring, I want to show you the refactored Java code. What you see here is a refactored Java code, which is a conversion of your COBOL to Java, and you will see the business logics being included in the process implementation layers. So for every single program, you will have an equivalent Java code available. Here is the downloaded Maven project, and under services, Under source, you will find the Java code being translated. So for every single component in the card demo, you will see an equivalent service layer and the implementation, which is where your refactored Java code is. With this, the first workflow is complete. You'll be able to view the results and you will be able to see the complete progress on the dashboard, which tells you with each and every step what was the progress, what was the success, and what was the failure. Let's dive a little bit into the reimagined world of mainframe modernization. Business rules are very crucial for reimagining your mainframe applications. The workflow is very similar to the refactor. You can add collaborators, specify your input source, and do the analysis. And very similar to how you select components for documentation, you can select components for business rules as well. I selected one online module to extract its business rule. And once the process is complete, you will be able to review the extracted business rule in the S3 bucket as well as in the online viewer. Let's select the component for which the business rules are extracted. And here is the summary. It tells you the high level operational workflow of the particular component that was extracted. It gives you a metrics on how many if logics, how many perform statements to kind of give you a guesstimate on how complex this program could be. It also gives you the data source of information. This particular program is a CACS program. So you have CACS transactional file, and there is being a cross-referential operation. And it gives you a BMS preview on this is how this particular CACS screen would look like. You will also have the extracted field details to design your data for testing. And here is the high-level flow of the program. You can deep dive into each of the flow, and you can toggle back to the overall high-level flow to understand how overall a program works. You see initialization, there is a user action that takes you to the account validation, and what happens when account validation is success, and when it fails, it goes to cross-reference. And this helps our developers and analysts to visualize the programmatic flow, identify what are the business rules that are very relevant for your reimagination process, extract them, and then take forward with the reimagination journey that includes creating tests, doing code scaffolding, creating user stories, and tasks on Jira. You also have the Gherkin scripts in the form of given, when, then, which tells you what are the scenarios for you to create test automations and validate your acceptance criteria in an agile world. For every business rules, we write a given, when, then Gherkin scenario with which you can integrate these tasks and user stories to an automation script and run through entire automation workflow during your reimagination journey. The next net new feature that we have launched for public preview is called Reforge. Let's show how Reforge works. Reforge is typically used to improve the readability and maintainability of the Java code. We provide functional equivalence on the transformed Java code, but our goal towards increasing or insisting or raising the high standard is what has led to the Reforge. We wanted to improve the maintainability and the readability so that our modern Java developers can easily understand the code and maintain them in a longer run. All that we need to feed it to Reforge is the S3 source of a compiled transformed code from AWS Transform. After we do the 5-step process of analysis, decomposition, transform, plan, and refactor, we compile the code, make it runnable and executable, and supply that as an input. There is a second input which will list all the classes of Java components that needs to be reforged. Here are the example. I have a couple of classes which I have to put it onto a text file, load it back to S3, and supply that as an input and trigger the reforge option. You will get the output back into the S3 bucket, and you will be able to see the reforged results, something like this. I have a side-by-side comparison to show you the impact of reforge. On the left, this is a traditional functionally equivalent Java code, and this is the reforge. Sorry, I did vice versa. So this is the original code, and this is the implemented Java code on the left. So let's take through one particular section. I'm taking through the first override class. What you see here is a functionally equivalent Java code, and what you see here is the breakdown output of functionally equivalent Java code reforged, adding readable comments and making the Java program very idiomatic. It breaks down the complex nested if loops into simplex loops, reducing the complexity. Right now, in public preview, the limit of per component is 5,000 lines of code, and we will expand it as we improvise the service feature. Summarizing the overall feature, you have business rule extraction, you have Reforge, which is net new. You have a traditional workflow right from analysis documentation through the workflow of refactoring. And you will be able to track all the progress on the centralized dashboard, which will tell you the status of each steps that were progressed. Now, let's hear about what our customer says while using AWS Transform for their mainframe modernization journey. Starting off with one of our flagship customer, a leader in automotive industry, Toyota. We started working with Toyota on their mainframe modernization journey. The biggest challenge that we wanted to solve for them was preserving their application knowledge in spite of having a transitioning workflow. We identified a scope of 18,000 MIPS, 40 million lines of code, and we co-innovated to build AWS Transform for solving customers like Toyota's challenge. And with AWS Transform as a solution, we were able to reduce their discovery and planning of mainframe modernization journey by 75%. We were able to extract the knowledge of the application, improving the productivity of their business users and the modernization expert. That saved efforts which could have cost months, which is now reduced into hours, close to 90%. We were also able to help them improve the maintainability by breaking down their tightly coupled monolith chunk of 40 million lines of code into multiple business domains and accelerated their application modernization journey with AWS Transform. The overall modernization speed was up to 4x faster, and we are positioned to accelerate it even more further. These are very motivating. Our customer success is ours. And Brian Cursor, the CTO of Toyota North America, was delighted to say that AWS Transform made them do impossible things now possible, which is extracting their application knowledge and saving them from the transitioning workforce. Pegasystem, one of our partners and a leading industrial software vendor, has used AWS Transform to extract business rules and apply it in a reimagination of their customers' mainframe modernization journey. An application that historically took at least a year long to demonstrate a proof of concept and a pilot scale application, they were able to accelerate it up to 4x with just 90 days of delivery into the production. This is for a US state agency customer of Pega. NRI, a software company and also a service company based out in Japan, expanding their scope in global regions, have leveraged AWS Transform and reduced their analysis and getting the project started from ground time to significantly in week compared to months before. With AWS Transform, this partner and a software service vendor were able to deliver quick POCs and analysis report out to their customers that speeded up their mainframe modernization journey. Typically, a customer project takes around 200 to 250 days to get started because of various complexity involved, and we are making them simple with AWS Transform. There are several partners who worked with us through the public preview phase until the launch and have been successful in building their modernization practice and delivering projects with AWS Transform for their mainframe modernization customers. Cognizant, Capgemini, Accenture, HCL Tech, Pega, Kyndryl, NRI, Infosys, and DXCs are all our elite launch partner. And this partner list is going to significantly grow as every GSIs and partners will leverage AWS Transform to build their modernization practice and make their customers successful using our GenAI acceleration. Thank you for your learning and be curious in terms of knowing AWS Transform and get your mainframe modernization journey started with this information. You will be able to navigate to AWS Transform into our console websites, and you will also have more and more artifacts coming up to enable our field and customers.
Thanks for joining us today, everyone. We enjoyed sharing what we're bringing to the market here with AWS Transform for Mainframe, and we look forward to hearing more and watching what you build with the service. Thank you.